All right, let's talk about vectors and vector review. Okay, I already kind of briefly touched on this in the last video. But let's talk about the I hat, the J hat, and the K hat. Okay, the I is just means that that's the magnitude 1 in the X direction. Okay. J is a magnitude 1 in the Y direction. And K is magnitude 1 in the Z direction. Okay, so we commonly refer to this one as horizontal. Ooh, I can't spell horizontal today. This is your vertical. Ooh, what just happened? Sorry. And this one is the into and out of the page. So that's like our third dimension. We won't be doing that one very much, but you should know it's there. All right, so for an example, we could have written for our acceleration. The little half arrow on the top tells us it's a vector. And it may be written as 6i plus 3j plus 4k meters each second squared. So this just gives you the dimension in the X direction, the dimension in the Y direction, and the dimension in the Z direction. Okay, so if you need to find the overall magnitude or size, okay, remember magnitude is just a fancy word for size. If we're doing 2D motion like we did a lot of last year with projectiles, you would find it by taking the acceleration is equal to the square root of the acceleration in the X direction squared plus the acceleration in the Y direction squared. Three-dimensional is similar, but now we have to add that K term. So it's still the square root of the X term squared plus the Y term squared, but now we add the Z term squared as well. Okay? If we're trying to determine direction, okay, if you remember from math, when we have our axes, we have quadrants 1, 2, 3, and 4. So when you're determining direction, if we are looking at two-dimensional motion, the angle is going to be equal to the inverse of the tangent of the Y component of the acceleration, if we're still talking about acceleration, divided by the X component of the acceleration, okay? If it's in quadrant 2 or 3, you have to add 180 degrees. Okay, so then components, which we did a lot with forces last year. We should have done a lot in projectiles too. It seems like we rushed through that one a little bit. The X component can be found taking the overall acceleration times the cosine. Now remember, when you're on an incline, that will change a little bit. If you're looking for the vertical component, it's usually sine, okay? These can change depending on the situation. So make a note of that. It could change some, okay? All right, so again, we're talking quadrants. We are mostly looking at quadrants 1 and 4 because usually we will be doing time and you can't have negative time, okay? So most of the time we're going to be here. So if we were going to look at this vector A, it would have components horizontal and vertical, okay? So that's what I'm talking about when I'm talking about these horizontal and vertical components. All right, last but not least are a couple of things we aren't really going to do in here, but they are helpful to know. If you are adding vectors, remember you can't add vectors unless they are in the same direction. So your equation will look like each piece added together. With each of your vector directions, okay? If I had a vector B, oops, sorry, I don't know why it does that every now and then. And again, it has its 3 dimensions. If we needed to add these together, adding these 2 vectors together, you would just add their whatever value is in front of the vector. So for x, we would just add ax plus bx. We would add the I behind it. For y, we would add the y component of a plus the b component. Put the j, oops, that is not a j. And the z components. You would just add whatever number was there in front of those, and that's how you add them. It gets a little more difficult when we talk about dot products, and if it's a dot product, it means we have scalar quantities. So sometimes it's called a scalar product. So things like energy is a scalar, speed is a scalar. If you wanted to combine those things, you have to do a dot product. Again, we won't really be doing much of this in here. But for a dot product, you would multiply them. And knowing your identities, if you multiply those, you actually come out with this AB cosine theta. And then last but not least, you may have to do a cross product. And a cross product is for vectors. So it's also referred to as a vector product. And for this one, we would write it A cross B. So if we were trying to do that, we would take the values in each of the directions. Oops, that was supposed to be an A, my bad. And then the BX, the BY, the BZ. So, in shorthand, A cross B is AB sine theta, okay? If you do a cross product between I and J, you get K. If you do a cross product between J and K, you get I. And if you do a cross product between K and J, you get I. Oh, I did that one twice. Oh, because it's on. Oh, you get a negative I. Sorry. All right. So, again, these two, we aren't really going to be dealing with these very much, but you should know that they're there. If they're talking about a dot product, it's scalars. If they're talking about a cross product, it's vectors. Vector quantities are things that have a direction, so acceleration, velocity, displacement, things like that. All right, I hope this helps. If y'all have questions, make sure you let me know. Have a great rest of your day.